Hi, my name is Jackie. I was inspired by the contrast between my parents' thriving garden and my own repeated failures to keep plants alive to create DataSprout, an IoT environmental monitoring system designed to track plant health in real time. What started as a plant care tool has grown into a modular telemetry platform capable of supporting other applications such as smart automation or general purpose sensor networks. DataSprout integrates sensor hardware, firmware logic, and a full stack web application to collect, store, and visualize environmental data. At the core of DataSprout is a Raspberry Pi 5 running the Debian GNU Linux 12 operating system. Connected to it are a DHT11 temperature and humidity sensor and a 16 by 2 I2C LCD panel, a 40-pin GPIO breakout extension board, and DuPont jumper wires link the hardware components onto a full-size breadboard. The DHT11 sensor provides real-time environmental data, while the LCD panel displays this data using I2C communication. This setup enables the Pi to monitor and present environmental changes live. The firmware logic written in C handles sensor communication and display output. After booting, a bash script executes a C binary to collect data using the no-hub command. This allows the program to run continuously, even after user logout or session end. The script is coded so that, at every 30 minutes, the firmware reads temperature and humidity data from the sensor, updates the LCD, and inserts the data into a MariaDB database. This cycle continues until either the Raspberry Pi is shut off or the process is explicitly stopped using another script, ensuring a hands-off and reliable data pipeline. The web application is built using a modern full-stack architecture, React on the front end, Node.js with Express on the back end, and MariaDB as a database. Importantly, the data insertion to the database and the web server, which requires data fetching from the database, operate independently. This architectural separation ensures the web app can fetch the latest data without disrupting collection. A bash script launches the data collection and another launches the app server and client, making deployments easy and modular. Users interact with the app through a React interface, selecting custom date ranges with drop-down calendars. When a range is selected, React updates its state and triggers a useEffect hook to call two backend RESTful API endpoints, /API/data for raw readings and /API/stats for computed statistics. The backend uses Node's exec function to run a compiled C binary for data retrieval. Results are returned as JSON and rendered dynamically on the front end. To make the data meaningful, the front end uses the d3.js library to generate responsive, animated, and real-time line charts for temperature and humidity. Each chart includes a number of aesthetic and interactive enhancements for improved user experience. Tooltips for closer data inspection, smooth animations for transition and updates, formatted axes for readability, grid lines for visual guidance, and gradient fills to enhance visual appeal. This integration of backend data with dynamic front-end visualization enables real-time intuitive monitoring of sensor metrics. Additional stats like minimum, maximum, and average are also displayed alongside the charts to give users a greater understanding of the selected data. DataSprout is more than a plant monitor. It's a scalable, modular IoT platform. Its architecture supports real-time environmental monitoring, historical data analysis, and remote access through a clean web interface. By decoupling data collection from visualization, it ensures smooth operation even during long-term deployments. Whether it's for home plants, smart houses, or research projects, DataSprout delivers a responsive and extensible solution for sensor monitoring.